Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on linear relationships and making predictions. This video includes some practice problems and will be great to help you practice and develop the skills you'll need to become an expert at linear regressions and making predictions. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this video. This is designed for practice for the following skills. The student should already be able to make a scatter plot on the TI-84 calculator, to find the correlation coefficient on the TI-84 calculator. Your diagnostics should be already on. You should be able to check for evidence of a linear relationship, check the scatter plot for a linear trend and compare a table value to the correlation coefficient, make a scatter plot with the regression line on the TI-84 calculator, and if there is evidence of a linear relationship, use the regression line to make predictions. And as always, a TI-83 calculator should be okay, as well as the TI-84. Review of the TI-84 calculator: scatterplot, regression line equation, scatterplot with the regression line, and predicting using the regression line. Here is a review and an example to review those skills. Employees in a company are given training to help them improve their ability to make a good quality product. The number of pounds of defective product for a month's work of production, 100 batches, for 6 randomly selected employees is recorded below. So we have X to be our hours of training, 1, 5, 6, 8.75, 11, and 12.8. And the pounds of defective product, 16.50, 14.00, 13.70, 12.00, 10.80, and 3.63. And we're going to make a scatter plot of the data, find the best fit regression line, sketch the regression line on the scatter plot, and use the regression equation to predict the pounds of defective product for an employee with 7.5 hours of training. So first we're going to make a scatter plot. Remember that the first step is to choose Stat, and then Edit under the Edit menu. When you do so, your list should appear. Remember that we want to put our X numbers in list 1 and our Y numbers in list 2. In this case, hours of training will go in list 1, the pounds of defective product into list 2, so that our data is paired. 1 with 16.5, 5 with 14, 6 with 13.7, 8.75 with 12, 11 with 10.8, and 12.8 with 3.63. Notice your calculator won't type the end zeros. Next, we will hit Second, then Stat Plot above the Y equals. Select Stat Plot 1, and you should get a screen that's similar on the screenshot. Make sure your plot is on, that you have selected the scatter plot that's the first option. Your X list is in list 1. Your Y list we put in list 2, and we like to choose the largest mark there to the left. It just makes them easier to see. If you will then choose Zoom and then number 9, Zoom Stat, that will give you the scatter plot. If you would like to select Trace to see the data values, you can double check that your numbers are all correct. You could also select Window and put in appropriate values in your axis values by hand, and then press Graph. Next, we are asked to find the best fit regression line. Stat, and then over to Calculate, and choosing number 4, the linear regression. Typing in list 1, comma, list 2, comma, and then y1. Remembering to find y1, we go to vars, yvars, and then function. At that point, we then press enter. Remember, we will then get the linear regression, and that gives us our linear regression. It's very important that you use the y1 or you will have to type in the equation into y yourself. If you have a newer form of the calculator, you'll get a screen that looks like this and input your information into the submenu and then press calculate. Again, just telling it that your X is list 1, your Y value is list 2, and that you want to store the regression in Y1. Now we're going to sketch the regression line on the scatter plot, and this will give you the graph. Excuse me. Select graph, and it should just sketch that line through your data. The D part is to use the regression equation to predict the number of pounds to predict the pounds of defective product for an employee with 7.5 hours of training. Recall that our regression equation is y equals negative 0.9227x plus 18.6231. And I think I kind of skimmed that over on this part. Here is your linear regression equation, and our A comes here, which is negative 0.9227x plus 18.6231, and that's your B, and that's where those numbers are coming from, and that gives us the equation. This green box is our answer for this part B. The C is still the same, and that's our answer. And to make our prediction, we just plug in 7.5 in for our X, and then type it in on the calculator. That gives us 11.7029, and we want to round that to the same number of decimal places as our defective product, so we should really round that to 2 decimal places. Or we can type in y1 parentheses 7.5, and the calculator will plug it in for us, and we get approximately the same answer, especially if we round to 2 decimal places. 11.70. But remember that regression equations should only be used if there is a linear relationship. In the next examples, we will check for evidence of a linear relationship before using the regression equation to make predictions. And before we get to those, let's pause here and we will continue this in the next video.